name is Kaushik. I'm an Android engineer by training. I'm known in some circles of the internet for having started this Android developer podcast called Fragmented. So if you're a listener of Fragmented, thank you so much. I've actually, thank you. I've got a couple of stickers, so if you're interested, definitely come and meet me after the talk, and I'll be happy to pass some of these stickers. But for my day job, I work for Instacart. Instacart is one of the biggest online grocery delivery companies in the US and Canada. And for my day job, I spend a lot of time with both the iOS teams and the Android teams. I try to take the best ideas from both teams and I try to cross pollinate. I try to apply them on the other team. What I've noticed in the process is there are a bunch of problems that are common across both iOS and Android. And in today's talk, what I'd like to do is maybe share some of those problems to begin with, and also suggest like an architecture solution that has worked really well, and I think that'll solve all of your problems, both across iOS and Android. So let's get started right away. The agenda for today is I want to share some of these problems that are common across both platforms. I'll then suggest the architecture solution that will solve all of your problems. And then after that, I'm going to spend the lion's share of this presentation on the implementation portion, because I think this is where things get really interesting. I'll share code snippets, I'll share examples so that you can look at a lot of these code snippets and go back and hopefully apply a lot of these changes in your existing app. And then depending on how much time we have, I'll try to do a quick recap at the end and maybe field some questions and answers around this. All right, so what are some of the problems that we see today on both Android and iOS, right? I think in the end, what we do is we take state, we take data, we take state, and then we just morph it to show it in front of a bunch of pixels, right? Managing UI state in the end is the most important thing that we do as app developers, right? And you might think, well, the patterns that I have work great, right? What's wrong with MVVM? What's wrong with MVP? What's wrong with MVC? What's wrong with MVI? Well, the problem is we have so many patterns, but that's a different problem altogether. But you might ask, well, it kind of works, right? Google has come up with this view model, architecture components, everything is amazing. What is your problem, Kaushik? Well, here's the thing. Let's take a very simple example, right? So this is like a movie search example. You type in some search text, you hit search, it shows you a movie. You tap the details, that middle portion, it'll add it to the bottom list. And if you try to step back and imagine how you would build this in MVVM, you would have like a view model, right? So every time you search, you'll type a search text, it'll go into the view model. You'll probably hit like a network request. If you ever want, OMDB API is like a free API for movies. I love watching movies. I've built many apps with OMDB API. I love those people, so shout out to them. So you make the network request using like Retrofit or AlamoFire or your best favorite network library. It'll give you back a movie object. You take that movie object and then you apply it back onto the activity of the view controller, right? This is very straightforward. And individually, if you look at it, you're like, this looks very clean. Like, no problems here. That's good so far. Let's go to the next feature. In the next feature, I tap that movie poster. It goes back to the view model. The view model then does something. It maybe stores from the database or it pulls from a database. It does something inside my activity of my view controller. And then it comes back and then it applies it at the bottom portion of this activity or view controller, right? Again, individually, this doesn't seem too difficult. Like each thing individually makes sense. Here's where it becomes a problem. If you are the developer and you have to look at this view model, it becomes a little, and this is just 3 features on the most simple app you can think of, right? This is where it starts to get a little complicated, because if I say, hey, I see a bug on that middle portion of the screen, that view already now is being updated by 2 or 3 sources. And what I did for the purpose of this exercise, I actually took a screen from a basic screen from an app at Instacart. This is our shopper app, and I tried to follow the same process. It just got crazy. I didn't even finish the process of mapping all these things. And this is a very real case. I'm not even trying to exaggerate here. This is not hyperbole, right? There's a whole bunch of interactions. If I get a user report or a bug saying, hey, that install update is showing the wrong text, I don't know, I'll just walk to them, connect my phone with the debugger. How many times have you done this, right? And I'm let me try to see oh no, that event, this is 2020. We can't be doing stupid things like this, right? We need to come up with an architecture pattern that doesn't make me run behind my user, plug into their machine in a very creepy way and then debug their phone, right? Life is much better than that. We should be past that. So Existing architectures like MVVM, the problem is they don't scale with complexity. When you start to add way more features, they don't scale as well. That inherently is a problem. The other problem is like debugging is very hard. Like I mentioned, right? Like if something goes wrong, it's really difficult for me to find out because that same view is being updated through multiple channels in the view model. And lastly, testing is really hard. You know, every developer loves testing. You go to an interview, you go to talk to people in conferences, they're like, oh, testing is great. Everyone should be testing. You know, like I tell everyone to test. You ask them to open up their Android Studio folder and see the Android test folder and the test folder, zero tests, right? This, but it's not their fault though. It's not their fault. Like everyone wants to test. I want to test. But if you make testing difficult, I'm not going to be testing, right? Like it's a very simple rule. If you make writing tests that difficult, I'm not going to waste my time writing tests. I'm just going to be building features, right? So we need to come up with an architecture pattern that also like makes testing easier. And lastly, this is a pet peeve of mine, right? Usually a PM or a designer will come to you and say like, hey, I need to work on this feature. The Android engineer is like, oh, I'm free. I'll start working on this feature. They work with the PM, they work with the designer. There's like edge cases. It takes 4 weeks. Then they're like, oh, testing 1 more week. 5 weeks. Okay, great. Done. Let's move to the next thing. Then the iOS engineer comes walking by, right? They're like, oh, I got to build this feature, right? And they're like, yeah, it'll take 5 weeks for me. I was like, wait, what? Why will it take 5 weeks for you? We built the exact same thing on Android, right? Like, no, we don't use RX. No, we don't use like, oh, like Swift works this way. No, you don't understand. Like, Swift works this way. Like Kotlin is like easier with these things, or like Swift is better this way. I'm like, you can't be giving me these reasons, right? Like, if I open up the phone, they look exactly the same. How many of you have worked on both Swift and Kotlin? So a few hands. If you see, it's like very similar, right? Like there's like hardly any differences, right? Like you swap a bunch of keywords, funk versus fun, like always gets me, but like, it's like almost the same thing. Why is it so difficult today then to like still build these features? They should be similar, right? So that's basically what I sought out to do. I like slowly through Instacart, I've been trying to canvas both teams to start using a similar architecture pattern. Okay, drum roll. Which is the architecture that solves all problems? Any votes? No? Well, I'll give you the answer. It's MVC. Just kidding. Model view controller. No. We don't want to use that. So here's the thing. Like we are thinking about it wrong, right? It isn't MVC. It isn't MVP. It isn't MVVM. It isn't MVI. It isn't like this new framework that you bring in tomorrow, right? You have to be thinking about it very differently. There is no single architecture that will solve all your problems, right? Thank you very much. I'm going now. Like no, it's you should be thinking about it very differently. You don't have a single architecture that solves all your problems because you see, each of these architectures are very loose. They'll allow you to do anything. You can do good things inside the architecture, you can do bad things inside the architecture, right? In the end, what matters is what you do inside those architecture patterns. So I'd like to rephrase this. What you should be doing is you should have certain guiding principles. Regardless of any architecture that you use, think about these guiding principles and use these guiding principles for your architecture pattern. And I think that will like get you to a much better spot. So I want to change my agenda item and I want to talk to you about the guiding principles for each of these architecture. And a lot of these have been based on functional programming. Redux has been like a constant source. A lot of like these patterns that you see today have been inspired by Redux. Redux has done this really well. It's a little different the way you adapt it to mobile, and that's basically what I want to talk about. There are a lot of good libraries like MVRX, Mobius. A lot of these have done these pretty well. But what I want to do is I want to convince you that you don't need a fancy architecture or library. You can take your existing pattern and then apply these same concepts. So how are we doing here? Let's see. So we have guiding principles. There are 3 main guiding principles, and I'll keep it simple, right? The first is you should model your entire user interface as a single function. Now, what does that mean? A function is basically something that takes in inputs, and for every inputs, you get a corresponding output, right? It's as simple as that. If you try to step back and think about the advantages of this, there are a lot of advantages. Testing becomes easy, debugging becomes easy. Testing becomes easy because I don't care what's inside the function. I can just say, give me input x1, x2, x3, and I should expect this output, right? Your tests are as simple as that. You just like, and I'm not even like making this up. I'll show you some of the tests I've written. They'll end up looking like this if you can like get your architecture to function that way, right? Debugging becomes easy because I know like in places like London and like hopefully not in the US, but like, you know how these CCTVs are like exist where they track every single thing? If you put a CCTV camera there at the input and the output, you know exactly what's going into your function, and you know exactly what's coming out of your function. So assuming you run into some issue, you can turn on a feature flag and then start logging every single thing that goes into the input and every single thing that comes out of the output, and debugging becomes really easy, right? And I have done this in the past where I was like, I can for the life of me figure out why this bug is happening. All I have to do is turn on that flag. It'll tell me the set of 5 input events that went in. I literally have to take those 5 input events, play it against my test, and in all likelihood, you should expect the same output, right? So modeling your user interface as a function is very helpful in this manner. All right, so the second one is avoiding mutating state. This one is like a simple one. Everyone knows immutability is a good thing. Swift, Kotlin, everyone has talked about this. I won't belabor the point. I'll just give you one example. If I was buying my friend a new television set, right, and I give them this new television set, oh, congratulations, happy birthday, new television set for you, right, and I keep the remote, you know, and then every time like they're watching TV like a jerk, if I keep changing the channels, like that's basically what you're doing with mutations, right? Because you're giving this model object to this person. I have this model object right in front of me, but because of some background operation, like this thing keeps changing in front of me, it doesn't become predictable, right? So whenever you think about like immutability, like it is a virtue. Try at every point of time to keep things as like immutable. Don't like mutate state as often. That's the main principle. And lastly, this is just more a generic principle. I won't go into too much about this for this talk, but if you look at the tests, it'll become evident. When you try to come up with your architecture pattern, you should try to come up with a mechanism that allows you to test at a business level, right? You shouldn't be writing things saying like, oh, expect this function to exist. No, in the end, you want to be testing at the business level, right? As a user using your app. So that's like just the last thing that I'll leave there. Let's focus now on like the implementation. This is where things get a little interesting. It'll also get a little heavy. There's going to be a lot of code, so like I'll try to walk you through as slowly as possible with these things. But this is like the interesting portion, right? I'm going to be using MVVM as an architecture pattern just as a benefit, because I've noticed that MVVM right now is very cool with the iOS people. Android people have been using this for a long time. Just kidding. But it doesn't matter what architecture pattern that you use is like, regardless of both of them, what you do inside them is what matters. Again, I just want to like repeat that point. So let's talk about the implementation. How many of you have used RxJava or RxSwift? Oh, wonderful. Pretty much everyone. So that's great. So yeah, I'm going to be using a lot of RxJava and RxSwift. You don't have to use RxJava or RxSwift, by the way, because this is a common question I've gotten with this pattern is like, oh, I don't want to use Rx tomorrow. Like I'm using what is it, Combine or like Flow or Channels or like one of these new things. You can totally use them, because in this architecture pattern as well, I'm not using any of the Rx black magic operators that you would expect to exist only in one of them. All right, so let's go into like the implementation mode. So this function thing, right? I had like an input and an output. Keeping this in mind, if I go back to MVVM, if I wanted to model this entire user interface as a function, how would I do this, right? To me, what it looks like is always, I'm not sure if you attended some of the MBI Jetpack Compose talks, right? Like you want your activity or your view controller to be very simple and dumb. You don't want any fancy logic in that. And the reason you don't want that is because the more complexity you add in different parts of the app, that means when you test, you have to test those parts of the app too, right? So I want to keep all like the logic for this inside the view model, right? So if I think of my view model as being the primary source or driver of the user interface, what I'm going to do now is, instead of the activity having multiple points of contacting the view model, I'm going to have a single channel, a single input channel for my view model. And I'm going to have a single output channel in the view model as well, right? So now all the input signals are going to be sent in through that input channel. Then I'm going to do like some like fancy stuff. Like we'll get into these things. Don't worry about it too now. Don't worry about it for now. We'll just convert this stream of multiple events that are coming in, and we'll send them out as a stream again back outside, right? So in this manner, what I'm going to do is the previous MVVM thing, which had like multiple forms of communication, I'm just streamlining them to always enter the view model through one single point and exit out of the view model through another point. Right? Again, a lot of this is conceptual woo-woo. Don't worry, we're getting into like code very soon. So like this will start to make a lot of sense. So this, if I take that principle about modeling my UI as a single function, this is how it would work in like the view model phase. All right, so let's focus on the first bit. Let's talk about like the inputs. I'm going to do 3 things. I'm going to come up with a name. like because always you need a name to talk about something. This name is not any glorious. I'm not taking great pride in this name. It's just a very generic name. If you want to change the name, go ahead, change the name. But for this talk, I'm going to use this name. And then I need to come up with a data structure, right? If I have these input events, I need to like package it in some kind of a class or some data structure. So we're going to talk about what data structure to use for this portion. And then finally, I need to transport that from the view controller or the activity into the view model, right? So those are the three things we're going to try to do. The name I'm going to pick is actually view event. Everything I'm going to prefix, any new data structure I'm adding in this architecture pattern, I'm going to prefix it with view, right? And because in the end, it'll like, when you see the final flow diagram, it'll start to make sense. But I'm going to call this a view event. What is a view event? Anything in your activity or your view controller that can spawn a change in your user interface. I call that as a view event. So like in the movie search example, right? If I type for a movie, I hit the search button, it basically then would cause a search movie event, right? That event will hold the information necessary. The data structure I'm going to use is like in Kotlin, I'm going to use a sealed class. Sealed classes are like amazing for multiple reasons. One, if you use a sealed class, then it'll force you to like write all your view events there. So you won't have like someone like me come to your code base, like, who doesn't understand the code base and start creating view events in other places. Sealed classes help like a lot with that from experience, I'm telling you. Inside the sealed class, I'm going to actually have a data class. Data class is, again, multiple good things with the data class, but I'm not going to spend too much time with this. The important points to remember, though, is it extends the view event. I have a search movie event, and I can now add all the other events that I talked about nested inside this view event data structure, right? I also do some things that some of my colleagues don't like, but I like it, and that's basically also have like a screen load event. Anytime my activity or my view controller like is resumed, if you know like Android out here, like the lifecycle on resume, every time on resume happens, I send an event called screen resumed or screen load. Because many times we have functionality saying like, oh, can you refresh the data? Can you do these things, right? Anything that can cause a change in my activity or my view controller, I want to model that as an event. So I also have things like view resume. If you're an iOS developer, I think view did load is like the equivalent event. So like those kind of things, I model every single thing I can as view events. Add to history, you can just add a whole bunch of these things. This is the one thing I really like about Swift. Enums in Swift work way better than like seal classes and data classes because of things like this, right? It's so nice and clean. So this is the one time I'll like give my iOS colleagues some credit, and I was like, okay, this is like pretty nice. The data structure looks basically the same in Android and iOS. So we've come up with what the view events are supposed to look like, right? So we know what the data structure looks like. The final thing is we want to transport these into the view model. How are we going to do that? Inside the view model, I'm going to only have a single function called process input. Now, what process input does is it takes an argument of type view event. So you remember that whole like single channel input output thing? Literally what I'm going to do is I'm only going to expose the process input function so that the only thing that's the view model that is taking in is view events, right? So this is almost like me enforcing that pattern. Now that you have the view events, what do you do inside the view model? You need to store it somewhere, right? This is a stream of view events. It's not a single view event. So typically what you would do is you would store this like in something like an observable. In this case, I'm using a published subject. If you have heard Fragmented, you know I don't like subjects that much. This is the one case where it's okay. It is fine, trust me. It's private. It's like within the view model. Nothing is going to happen. Like nobody's going to mess with it outside of the view model. So in this case, it's fine because it helps me store. It acts as both an observable and a consumer, right? So I'm going to use a published subject. If you're an iOS developer, this is what the code looks like. This is like the kind of things that I was saying, right? If you look at the top bit and the bottom bit, like they're almost the same. Like you can barely tell the difference between these two snippets. All right, so that's the input. Let's table that for some time, right? We got the input channel like covered. Let's talk about the output channel, right? For the output, again, naming convention, data structure, and how to transport this outside, right? For the naming convention, I'm going to just use ViewState because this, I think, is what is ViewState, right? What I want eventually is a data structure that basically describes the entire state of my activity of my view controller. If I look at your ViewState object, I should be able to tell exactly what my user is looking at. I shouldn't have to like grab their phone, look at the phone, and then confirm. Just looking at their view state should tell me exactly what I'm expecting to see, right? So in terms of a data structure, I just use, again, a very simple data class. But I want to call out some things which I think are very important here. First, I don't store any model or entity information. This is a common thing that people get very like they get confused and they get this wrong. Say I'm doing the search, like I'm hitting OMDB, I'm hitting a search, and it's giving me a movie object, right? Or I'm making a database request, and I'm getting a model object. Do not embed that inside the view state. What you want in the view state is just a bunch of very simple primitives like movie title string, movie poster URL, like genre information. This will land up like towards the end you'll start to understand why I emphasize these things. You don't want any model information inside the view state. The view state is literally just like a one-to-one stream to what you see on your activity or your view controller. Okay, so we know what the data structure is on, and this is like just basically pointing out that like a single view state data class should describe the entire activity or view class. Like that's very important. It isn't just portions of the activity of the view controller. It has to describe the entire screen. All right. This is what it looks like on iOS. I'm going to be using a struct for various reasons. Nothing fancy here. Notice that everything is, again, I'm using vals and lets. So again, I'm trying to like reinforce that immutability principle. Okay, so how do I transport these things outside? Don't worry about how we're going to take this view events, transform them, and convert them to like the view state. We're going to get to that very shortly. But assuming somehow I can, given that I have multiple input events, I'm going to have multiple output, right? Like if there's a single input, single input channel, single output channel. If you throw in multiple events, you're going to have multiple output events. And because that output view state has to be modeled as a stream, the easiest way to do that is an observable. So I'm going to use an observable. I'm not using a function. Like does anyone remember what I called my input process function? I almost gave it. What was the input function? The name for the view events. Anyone remember? I think someone said it, but yeah, process input. So I use process input. In this case, I'm not using processed output or something. I'm just exposing the observable directly from the view model to the activity of the view controller. Now you might say, oh, that's like a no, you shouldn't be doing that because you can mutate and like you can do these things. If you've used RX enough, you know observables are inherently immutable, which means that the observables themselves can change, but you're not going to change those. If it emits a view state and I meddle with that view state, like the observer is not going to care, right? So it's inherently immutable, which is why I'm comfortable in this case just exposing the view state directly to the activity of the view controller. All right, and this is just like finishing that loop. So you saw from there, like the view model like sends this to the activity of the view controller, the view state. And this is basically what the code looks like in your activity or your view controller. This is almost like 101 RX Java or RX Swift, right? Like you're just simply taking like the view state and you're binding it with your views. The important part here is to realize that the logic is almost dead simple. It's like take image view, set the image URL. Take text view, set the text, right? The logic is almost like super basic. I gave this example like in Swift, but yeah, I mean, Kotlin would look very similar as well. All right, so let's recap. So we have an input. We call it view event. We send it into the view model through this function called process input. We now have the output channel. We call them view state, and we expose them out as an observable. Now we're getting to the fun part. This is where like all the magic happens, right? I need to take this subject that I have of view events and transform these into an observable of view state. So okay, how do I start off with this? I have the view event subject. What I'm going to do is I'm going to flat map these. If you've used RX, you should know flat map is basically taking an object and transforming it into an observable of another object, right? So I'm flat mapping each event, view event, to an observable of view state. So I check to see what the type of the event is. In the case of a simple one like the view resume view event, I'm literally sending an empty screen with maybe like a toolbar title or something very basic, right? So I return an observable here. This works great. If it's something like a search, like the search movie view event, it's a little more interesting because now I'm going to be doing a network request, right? What I do here is I check to see what the event is. I then have like a do network request function. I haven't written the details here. You can use retrofit, alomofire, like whatever you want. It returns an observable of a movie object. I don't want to return that directly in my view state. Remember, you don't want to embed that inside your view state. So I have another mapper function that just takes that and converts it to a view state. I return it out, right? Done. Like it's as simple as that. I've converted view events to observable of view state. There's only one problem. doesn't exactly work. Just like because I sped through that, you might think, oh yeah, that works great. It doesn't actually work very well, because there's certain things that you have to realize. There is an accumulation function to the view state that you might have missed if you didn't like really catch what I was saying. Say I have my full view state that is like describes the screen, right? It is a combination of three parts. Let's just call it toolbar title, search details, and search history. When I have the view resume event come in and I return my first view state, the only thing it knows about the screen is the toolbar title. It basically doesn't have any idea about other parts of the app, right? The next event can come in, which is probably what it probably would send in the view state is like nil. Remember, there's a single output channel. So in the end, what you need exiting out of the view model is basically like a single view state for any event that comes in. So now if I have a search movie view event, what happens is it affects only the search, this part, like this, the search details part and the toolbar title. If I have my other final event come in, say like add to history, this would only affect this portion, right? The add to history event would have no idea what the toolbar title is. It doesn't care, right? It's like, hey, I'm just here to add the history. I'll just take care of this portion, right? So what we need is some mechanism of like remembering what the view state was. So every time this event comes in, it'll say, okay, I'll do my thing. This is the interesting parts of the view state that I'm going to be handling. I'll take everything else from the previous view state, I'll merge the two, and then I'll send that. That's really what we want. We want some kind of accumulation. So how do I do this? It's very simple, right? I basically just, my option one is I'll just store this temporarily inside the view model. This is just in code. I'm trying to illustrate the same example where like these red lines actually return the view state, and each red line here has no knowledge of the other view event as the transformation happens. So option one, I just store a variable there called previous view state. Job done, right? Like every time I emit from here, I'll store this in the previous view state. So that way, when the search movie event comes in, it'll take network result to view state. That's my new view state. I'll just update the existing previous view state and then return the previous view state. Why is this not a good idea? Anyone? Mutability. There we go, right? Like always, like that's another guiding principle. The big problem with previous view state being mutable is, imagine I have my view model with 20 lines. Some junior developer, well, I'm not going to say junior, like even like someone like me, I can come in and I was like, oh, I need the view state to be different. I'll just update the view state, right? That's it. Like, remember, it's like the TV thing. Suddenly, this beautiful function flowing thing that you have, like, is all just blown out of the window because someone decided to come and just update the previous view state, right? So this isn't like a recommend. Like, this is probably not what we have to do. So, is there an operator maybe that helps emit my last object with every new event, right? So think about it. If I could set up somehow the initial state, and then with every event emission of my observable, if I could like get the previous view state without me having to store it, this would be pretty easy, right? If you've dealt with functional programming or like RX Java enough, the scan operator is like literally what this was built for, right? Even look at the diagram, it's like almost exactly what I was trying to explain, right? So you basically like take the previous view state, it comes into the new event emission, it adds one part, it then comes back to the next thing, it then adds the next part. This is candidate like usage of what we should be doing. So let's like quickly run through the code and see what this would look like in terms of the code. So this is the scan operator. I start with a seed view state. I have my previous view state and I have the new event being emitted. Then I can go back and do the same things that I was talking to you previously about, right? Again, view, event, subject, I'm doing like the same things. And in this case, you have to understand, I'm not doing anything very different. Someone is still storing the previous view state, right? But in this case, it's kind of okay because that someone is not you. And that's what matters, right? It's the observable, it's the chain that stores the previous view state, right? And if the computers can take care of this, I'm always with the machines. Like the machines should be handling all these things. The minute you bring in human beings, they complicate everything, right? So in this case, the stream is actually holding the previous view state. So you see that parameter in the Lambda block, that previous view state is being provided to you. You're not storing it anywhere. You can't go and update that manually anywhere. So this is the advantage with the scan operator. So this, like we're following like the exact same thing. Okay, now, so far we have come to a point where we're like, okay, great, everything sounds amazing. View events get transformed to view state, observable view state, all problems solved. Well, not really. A very common example you might find, like you know how I mentioned that a view state should help sort of like dictate exactly what you see in your screen or controller. There are like these use cases that don't exactly fall in the boundary of a view state. For example, you can have alert dialogues, you can have toast notifications, navigation. Think about navigation. Say my view state had like a navigate to screen B Boolean flag. You mark it as true, you launch the next screen, you hit the back button on Android and you land up here, you land up in an infinite loop, right? Alternatively, you can like write a timer operation, clear these things, but that's like way more complicated. The better way to solve this is actually introducing another data structure called view effects. I call this view effects mostly because I think of these as side effects on the UI. They're actually very similar to ViewState, but much simpler. They don't need to do any scan operation. They don't need to remember the previous stuff. All they need to do is just have like a single one-time operation on the UI, right? So I'm going to actually also do something a little different. In order to make these transformations easy, I'm actually going to introduce another private object called view results. Hang with me here, and like once you see this entire flow diagram, it'll start to make sense. I'm going to take the view event like before. I'm going to perform my business logic, right? Like, you know, the network request, database request, anything I have. I'll perform this business logic outside. I'm going to wrap these in a private object called view result. The view result is again private to the view model. So my tests, my activity, my view control, they have no knowledge. It's almost just a convenience object. You don't even need to use it. I use it mostly because what I then can do is I can then share that. If you use RxJava, again, the share operation sort of like makes this stream reusable. And I take one part of that stream, I use it to do the same thing that I talked about to convert it to view state, and I take the other half and I convert it to view effects, right? The advantage of doing this is both view state and view effects are now completely independent, right? And this is very important because say you have a functionality where you're trying to delete a movie, right? And you say like, hey, do you really want to delete the movie? I don't want to change my view state. Everything about my view state is like the same, but I want to pop up an alert dialog saying like, hey, are you sure you want to do this? So the view state and the view effects have to be independent. And this mechanism of like splitting the stream in two ways makes this a little simpler to handle. There are multiple ways to handle it. This is just the way that I've chosen to do it. So let's quickly run through and see what this looks like in code, right? So I take the view event subject. I'm actually going to go back and do the simpler thing. I'm going to flat map every event, convert it to a view result, and this is like where I do my business logic, right? And if you want to reuse things across view models, this is the portion where you can reuse a lot of stuff, where you're taking the event and converting it to like a view result. I didn't tell you what the data structure looks like, but it's very similar to like the other things like a view event. It's in this case, it's an enum. You can use seal classes and data classes in the case of Kotlin. Notice here though that model entity objects are okay. Because this is business logic, if I do a search for my network request and I get a movie object, I can embed that sucker right inside the view result here. Like that's totally fine. Because what I'm going to do then afterwards is transform that into view state and view effect, right? So I've converted these to like a view result. This is again very simple code. Previously I was taking this and directly transforming these to view state. Instead, I'm wrapping them in a view result object. Again, this is just more code. I'm hitting a share. Now what I'm doing is I'm making the stream reusable. So I have a private view results in my view model. I can take that, transform one side to view state. You've seen this code before. It's the exact same thing. You have to remember, view state is the one that needs this whole scan remembering the previous thing. View effects don't need this. So I've taken the view results. I've done the scan operation. Much of this is pretty similar to what you would expect. This is what it looks like for view effects. It's much simpler. I take the same results. I'm literally just doing a map event and I'm sending down like view effects. I store both of these as view state and view effects, and these are like internal to the view model, right? So you remember how I told you there's a single input channel and a single output channel? I may have lied, or like at least I'm not going to like be entirely like fair. The output channel is both view state and view effects. So it's kind of the same thing, but not exactly, right? So it's like two output channels, but really they serve independent functions. All right, so where are we right now, right? This is just basically the sample code of what it looks like when you bind. You've seen this code before, by the way. This is when you bind the view state inside your activity or view controller. This is like the simple logic. What it looks like for view effects is very similar. Like in this case, is almost one-to-one to view state. But in the case of view effects, what I'm doing is depending on the event, on the view effect being emitted, I'm doing different things, right? So like, see, I show a banner. If I want to navigate, like this is a good place to like throw a navigation event. And these are not remembered. So these are like almost like one-time things that you have to do. All right, so we're towards the end now, and we're doing good. What I want to do is I want to like recap and actually like tell you. I've thrown a lot of data structures, a lot of like these event stuff. What I want to do is try to make it easy to like just wrap the whole circle around. So we started with the activity or the view controller. We want to model the entire user interface as a function. We decided to do that with the view model. So we have created an input channel at the top and an output channel at the bottom. Anything, any user interaction or any change in my activity or my view controller, I model that as a view event and I send it into the view model through that process input function, right? So I've established only one entry point. I take that, I perform my business logic. It can be a network request, it can be a database call, it can be something internal or inside the view model. I transform that, I run a share operation and I store that as view results. I take one portion of that because it's a reusable stream. I convert one half to view state. I convert the other half to view effects. I take both of those. I add them as an output channel that's taken back to the activity of the view controller. I bind those with that logic that I showed you, and all is well, right? So like this is pretty much how like it works top together. Now, if you think I was bluffing along the way, to prove myself, I actually wrote my first iOS application and an Android application here. They're both like very similar. I started with the Android application a long time back, so it's a little different from the iOS application. The iOS application looks better because that's how the world is, right? All iOS apps look better. No. I promise. Give me a few weeks, and I'll make sure that the Android app looks even better than the iOS app. But you can look at the code. If you look at the implementation, it's almost exactly the same. You won't find like a lot of difference in like the terminology and the stuff that I've used. But more importantly, the thing that I really enjoy is like the tests. So if this is what the test looks like, don't worry about like reading through this whole thing. You can go to the code base and you'll see like a lot of these tests that I've written are meaningful tests, and they're actually very similar to what you would see. This is what it looks like for iOS. In iOS, it's like pretty much like the exact same thing. I've used the whole BDD thing, so given, when, then. So like a lot of these tests, literally what you do is like, you create the view model, you set up like at various events, you schedule the input events. So all I'm doing is saying send input event, send input event, send input event. And at the bottom, if you noticed, all I do is I set up an expectation saying, I need to see this view state, I need to see this view effect. Like that's all my tests are. Like you can see like all of the code is basically just me testing inputs and outputs. So that's what like the tests look like. In terms of like resources, you can look at the movie search application. I'm on Twitter at Kaushik Gopal. You feel free to like send a tweet if you have any questions. On Fragmented, there were 2 episodes where like I really bored Don to death with like these 2 things. It's episode 148 and 151. He did mention that he enjoyed them eventually. So like he's like, as much as he makes fun of me, like those are 2 episodes that I think that really talk about a lot of these concepts. I work for Instacart, so like if you're interested in doing things like this with me, then please send me your resume and like let's have a chat. So that's pretty much that I had. We still have like a good 5 to 6 minutes left for questions. So I'd really want to like field any questions that you have. And if you're feeling shy, what I've done is I've actually like created a whole bunch of questions that I couldn't cover in detail. So if you want to pick these questions, I'm allowed to give like a free mug to someone. So like literally just pick a question here, ask me, I'll give you a mug. So. But I mean, if you have any questions, please, like I'm happy to like take any questions now.